Hey everybody. This next unit we're going to talk a lot about equations and inequalities. Today we're just going to start with equations. What equations are, what are the different types of equations, what do they mean? An equation is just a statement that says two expressions are equivalent, right? We're going to look at three types of equations here. Our first equation says that 4 times negative 2 plus 3 equals negative 5, right? We have one equation over here on the left, 4 times negative 2 plus 3, and we're saying that's equal to this expression over here on the right, negative 5. So we have two expressions that are equivalent. Now, it's always a good idea to see, is this equation actually true if we looked at it? Let's use the order of operations over here on the left. 4 times negative 2 is negative 8 plus 3 equals negative 5, and negative 8 plus 3 is negative 5, right? So we can prove that an equation is true, right? This is a true equation. Okay? We stated that these two expressions were equivalent, and we proved that it is actually true, right? That's a true statement. Now, our second equation, we have negative 4 plus 1 over 6 equals negative 2, right? We can see if this is true. Negative 4 plus 1 is negative 3. So we have negative 3 over 6 equals negative 2. And if we do negative 3 over 6, we divide those or we simplify, that's going to give me negative 1/2 equals negative 2, right? There's nothing else we can do over here on the left side. So this statement isn't true, right? Negative 1/2 is not the same as negative 2. This is a false equation, right? We said that they were equal, but that actually turned out to not be true. So this is false, right? Statements can be false. That happens. Now, over here on the right, our last example, now we have some variables here. I mean, we could do some things. We could distribute this 3, right? That would give me 4x plus 2 equals 3x minus 21. But because we don't know what x is, x can be any number. We don't know if this is a true equation or a false equation yet. We don't know. So we actually call this an open sentence, right? It's open. It's open for interpretation. If x is one thing, it could be true. If x is another thing, it could be false. So 3 different types of equations. We can have true, right, when the two sides are equal, false when the two sides are not equal, and an open sentence when we don't know because we have a variable in it. When we have an open sentence, a lot of times what we want to do is find the solution. A solution is a value that makes an open sentence true. So if we have an open sentence, like here, negative 2a plus 4 equals negative 6, a value for a that makes the statement true is called the solution. So if I'm looking at this example and I have option A here, a equals negative 1. If I substitute negative 1 into a, negative 2 times negative 1 plus 4, does this become a true equation now? Negative 2 times negative 1 is 2 plus 4 equals negative 6. 2 plus 4 is 6. And now we have 6 equals negative 6. This is not a true equation. This is false. This is false. So A cannot be an answer. Option A. Option B here, we have A equals 1. Let's test that. Negative 2 times 1 plus 4 equals negative 6. Negative 2 times 1 is negative 2 plus 4 equals negative 6. Negative 2 plus 4, though, that's positive 2. So now we have positive 2 equals negative 6. This is also not true. This is false, right? So 1 is not a solution because 1 did not make this open sentence true. Let's try A equals 5. Negative 2 times 5 plus 4 equals negative 6. Negative 2 times 5, that's negative 10, plus 4 equals negative 6. Negative 10 plus 4 is negative 6 equals negative 6. This is a true statement. This is awesome. So this is true. Okay? So here we have an answer. Now, I'm a good test taker, so I'm going to make sure I test all my options here to see if I did this right. A equals -5. I got -2 times -5 plus 4 equals -6. -2 times -5 is 10 plus 4. And that's going to give me 14 equals -6. We got another false one here. So we only have one answer here that makes this statement true. So we say that this is our solution, right? Our solution is A equals 5. Let's take a look at another example. Here we have x equals -4 is a solution to which equations below? Circle all that apply. So here we have a possible solution. We have a value for x. I want to know, is it a solution? So first I have 2 times x plus 1. So let's do 2 times -4 plus 1 equals 7. 2 times -4, that's -8 plus 1 equals 7. -8 plus 1 is -7 equals 7. Not a true statement, right? This is definitely false because those are opposites. So not A. A is no good. Letter B here, we have 4 times 2x minus 1, right? If I use my distributive property, I do 4 times 2x, 4 times -1. That's going to give me 8x minus 4 equals -36. Right? We can substitute my -4 in for x. 8 times -4 and then minus 4 equals -36. 8 times -4 is -32. And instead of writing -4, I'm going to write plus -4. And -32 plus -4 is -36 equals, -36. That's true. True statement there. So letter B works, okay? Now we got one more we need to try because it says circle all that apply, so could be more than one answer. I have an equation here, but I have some like terms over here on the left side. You know, to make this easier, I would actually like to combine these. I'm going to think of this as 2x plus -5x minus 2. 2x plus -5x, that's -3x minus 2 equals 10. And now I can substitute that -4. -3 times -4. And instead of minus 2, I can write plus -2 equals 10, right? Those are the same thing. Scroll down a little bit here. And now I can do my multiplication. That's going to give me 12 plus -2 equals 10. 12 plus -2 is 10. So we have another true statement, which means that -4 was a solution for this option here. So when we look back up here to the original question, x equals -4 is a solution to which equations below? -4 was a solution for B, and it was a solution for C, right? Two equations